Well, good afternoon, everybody, and welcome to the fifth of our series of lectures on the transits of Venus. I'm Ron Brashear, Head of Special Collections at the Smithsonian Institution Libraries. I'm the curator of an exhibition some of you may have heard of by now called Chasing Venus, Observing the Transits of Venus from 1631 to 2004, which is on display in this museum. So if you haven't seen it yet, be sure you see it after this exhibition. If you've seen it before, see it again. And for those of you who will be watching this on the web, since this lecture is web archived, you've seen me give an introduction for 5 times now, so you're probably sick of seeing me, but that's too bad. We'll go ahead and continue with the introduction. The Chasing Venus exhibition and this lecture series has been funded by NASA's Office of Space Science Education and Outreach program, so we thank them for allowing us to gather together some people with great interest in the transits of Venus to talk to us. For the 1 or 2 people out there who don't know what the transit of Venus is, well, Venus, there's a picture of it from 1882. The last time it happened, it's going to happen on June 8th. 2004, just a few days from now, so I hope you have your plans in place. I know I do. But this afternoon, we're fortunate to have with us David DeVorkin, who will be talking to us about public interest in the 1882 transit. David is Curator of History of Astronomy at the Smithsonian's National Air and Space Museum. He got his MPhil in astronomy at Yale. He's had experience working around major observatories, including the Lick Observatory in California and the Yerkes Observatory in Lake Geneva, Wisconsin. But he happily grew interested in the history of astronomy and received his PhD in history of science at the University of Leicester, where he started his specialty in history of astronomy. After that, he taught at Central Connecticut University, worked at the American Institute of Physics, and ended up at the National Air and Space Museum in 1981. So he's been there now for a goodly number of years, really obtained some great expertise. He's written many books and articles on history of astronomy, including Science with a Vengeance, How the Military Created the U.S. Space Sciences After World War II, Race to the Stratosphere, Manned Scientific Ballooning in America, Henry Norris Russell, Dean of American Astronomers, and he recently edited a National Geographic Society publication, Beyond Earth, Mapping the Universe. David is also the curator of the fabulous Explore the Universe exhibition in the Air and Space Museum, and I urge you to visit that for an excellent overview of the history of astronomy and cosmology. But without any further ado, I'd like to now officially present David DeVorkin on public reaction to the transit of Venus, 1882.
On a clear, crisp December morning in the little Long Island village of Oyster Bay, New York, some 122 years ago, a 5-year-old boy was shown how to look at the sun by his parents and saw a sight that lasted with him all his life. 63 years later, Henry Norris Russell recalled for an autobiographical statement for the National Academy of Sciences that his parents had shown him the 1882 transit, apparently as a result, he claims, he gained a lifelong interest in astronomy. Well, as a biographer interested in Russell, I took that as a challenge. And about 10, 12 years ago, actually for the centennial of the 1882 transit, which would have been 1982, I looked into this briefly and had to convince myself that indeed he probably did see it. But this is the process. I'll be talking to you now about the process that I took to convince myself that he actually did see it. Well, the 1882 transit lasted for some 5.5 hours starting at 9:30 a.m. on December 6th, as seen from New York City. Okay. It was the last observed transit of Venus, as we well know today, and the next will come on June 8th, some 5 days away. While I was preparing this study of Russell, I became quite fascinated with the fact that Russell had looked at Venus and been interested in Venus throughout a long part of his career, and that he also felt it was an important part of his early life. I naturally was drawn to it. Well, there's no record, first of all, of the Russell family possessing or having access to a telescope. And since he made no mention that he looked at the transit through a telescope, I naturally began to wonder if he could really have seen the transit, let alone appreciated the event. After all, he was just 5 years old. Could a transit of Venus be seen without a telescope, even though the apparent Venusian disk is a mere 1/30th the size of the sun? Well, not long after I asked that question, I recalled when I was still at Yale that the historian of science, Bernie Goldstein, had asked exactly the same question. And he had discussed medieval records of transits of Mercury and Venus. And while the medieval records remain unclear, he did allude to a fascinating newspaper account of observations of the 1874 transit in the Hawaiian Islands that demonstrated that indeed a native culture, unaware of the transit, actually had recorded it, and seen by the unaided but protected eye. And then from a later study based upon the work of Jean Mies, and presumably a lot of others as well, we have come to know now, of course, which is obvious today, that the Venus transit was visible without a telescope. But interestingly enough, in 1882, asking that question, it wasn't too clear because I hadn't yet started looking at the historical literature. Well, with that question settled, I turned to two related ones. Was the weather clear enough in Oyster Bay to see the event? And if so, was it likely that a 5-year-old like Russell would have been taken out to see it, let alone remember it? As to the weather, I found out quite easily from the New York Times. It was most probably clear in Oyster Bay, as extensive reports of observing the transit came from Brooklyn, just a few miles to the west, as well as from Manhattan and also from New Haven in Connecticut. There was you've seen this picture before, and of course we're talking about the 1882 transit. That is the 5.5-hour transit here that was visible in midday throughout much of North America. In Hartford, there were observatories set up in front of the Athenaeum and in many, many other parts of the East Coast and across the Long Island Sound, and they all saw it. In fact, the day of the transit seems to have been near perfect, to judge from the many reports along the eastern seaboard. Okay, well, finally, would Russell have been shown the transit? That's the big question. Before I searched for local records in Oyster Bay, which was not accessible to me at that time, again, I searched the records in the New York Times for the week preceding the event, and that pretty much told me what I wanted to know. On December 2nd and December 5th, long notes appeared in the Times announcing the coming transit. The latter report, an 8-inch column on page 7, began, "Venus crossing the sun's face, how and where the transit may be observed tomorrow," and giving people who would be interested in looking at it, of course, information on how to look at it safely. Well, the report explained how small opera glasses could be used to view the transit if care was taken to reduce the light of the sun, or how the use of a heavily smoked glass filter could be used, and in fact it even gave instructions on how to smoke the glass. The report also provided exact times of ingress and egress of the tiny black disk of the planet, as well as where on the solar limb it would first appear. In addition to numerous newspaper accounts in the Times, New York Evening Post, and in the New York Tribune advertising the coming transit, there were a number of popular books of the day and also magazine articles announcing and also instructing how to view it. R.A. Proctor's popular articles appeared, as did a short book by George Forbes. In the wake of the 1874 transit of Venus, many accounts called for closer attention to the 1882 event. Unlike the 1874 event, the entirety of the transit in 1882 would be easily visible from anywhere in the eastern United States. Simon Newcomb's Popular Astronomy, published first in 1878 and then reprinted in 1882, highlighted the coming transit of December 6th, making the point that since this transit would be visible from all of the Americas, as one can see here, the entirety of the transit would be visible from the Midwestern and Eastern half completely, and parts of the transit from the West Coast, and from all of the Americas, of course. As almost every reader will be able to see either the whole or some part of this transit, we present a map showing the region of visibility. And he spent quite a bit of time then describing the transit in his book, Popular Astronomy. So there's little question that the reading public knew of the upcoming 1882 transit, that they knew it would be the last such event during their lifetime, and that it was something they could see for themselves. In fact, the Post ran a full column on page 1 in the December 5th edition, detailing, again, just as a reminder, how the public might make observations, and that the records of their observations could, in fact, be of scientific use. You could send your observations to the U.S. Naval Observatory. And I will come back to that at the end of the talk and show you what some people sent to the Naval Observatory. Well, since Henry Norris Russell's mother and father were both well educated for the day and very keen on observing nature, which is a key point here, they quite likely did not let the day pass without an attempt to see Venus. And it may well have been a topic of family conversation on that day, if not before it. Okay, sounds likely, but it's still speculation. Even though accounts in the New York Times and other places can give a certain credence to these speculations. A front page article in the Times the day after the transit, entitled Across the Sun's Face, took a full column on page 1 and 2 1/2 columns on page 2. And according to the Times, it was a real event. The transit of Venus, and I'm quoting, was a popular exhibition. And as it had been widely advertised in advance as the last performance for 122 years, everybody who could possibly get a sight of the show embraced the opportunity. Crowds of people throughout the city reportedly viewed the event. The numbers used to describe them, and now I'm paraphrasing, ranged from scores to thousands. Police were called to control the crowds, pushing to look through telescopes that had been set up by enterprising amateurs in the city parks. And good money was made on that day. The going rate was 10 cents a peek, and they had 5.5 hours. Even normally staid Wall Street was filled. A telescope was mounted on Broad Street, near the stock exchange. And the owner of this telescope, too, had all the business that he could possibly attend to. The brokers took as much interest, apparently, in the exhibition as the other men and boys about the city, again, paraphrasing the Times. Broad and Wall Street were filled, as the Times reporter stated, with bulls and bears, each with a piece of smoked glass in his hand, and when not engaged in scientifically examining the transit, they amused themselves by blacking each other's noses and faces. At one point, I thought I had read an account where they had actually closed the stock exchange, but I've never been able to verify that. That would have been pretty amazing. Well, the Times also reported observations made by students at Columbia College, the City College of New York, numerous private schools, and elsewhere in New York and New England. Meriden, Connecticut, in fact, closed its schools on transit day and announced the beginning of the transit with the tolling of fire alarms, the bells across the city. While clouds obscured the event from many more northern cities, observations from Princeton, Yale, and Harvard appeared to be fully successful. At Princeton, Professor C.A. Young organized a large photographic group. At Yale, 7 telescopes in the famous Yale heliometer were trained on the transit, the heliometer taking 237 settings of the 4 contacts and of the apparent diameter of the disk of Venus. Harvard College Observatory used its 15-inch refractor for timings and disk measurements. Both the New York Times and the Philadelphia Inquirer reported that even though the sky was cloudy in Washington, D.C., good timing observations were made, and that most American expeditions to other sites in the continental United States as well as around the world had been successful. Well, you could find similar reports in the Boston Evening Transcript, in the London Times. In addition to timings and disk measurements, all the reports noted observations confirming the existence of Venus's extensive atmosphere, and above all, for the purpose of this talk at least, the great excitement, the public excitement that the event caused. All this supports the popularity of the 1882 event, but none of it still clinches my concern that Russell's memory was indeed correct, because we've found that memory is often quite faulty. Well, the best way to satisfy that, I guess, was to make the ultimate sacrifice. Visit Oyster Bay and search out records. This, of course, was a considerable hardship, but historians have to do what historians have to do. The Nassau County Historical Society, the Oyster Bay Historical Society, the local public library, and about half a dozen oyster bars in the bucolic downtown of this still sleepy little hamlet more than compensated me for the effort. Now, the points I'll be talking about would be Russell's father's church, sitting right here. You can barely see the manse behind it. And today, of course, this is a bird's eye view from the late 19th century. Today, on East Main Street, the library was up this way and off in here, and the Historical Society was down in here. And the oyster bars were all down in here. Presumably, some of them were original. Okay, the local library provided access to local papers, of course. On Saturday, December 2nd, turns out the East Norwich Enterprise ran a note titled 1,000 Million Suns. It was an excerpt from one of Proctor's articles talking about determining the distance to the sun. It was lifted completely from Proctor without any comment that it came from Proctor as a romantic interlude extolling the scientific experience of the coming transit and the progress of scientific investigation revealing the true glory of the heavens, which is an important key for the state of mind of Oyster Bay folk of that day. Okay, next, turning to the records of the First Presbyterian Church, something quite in fact I wanted to see for many reasons, far beyond the transit, but the transit was one of the curiosities of my search. And here's the church today. Well, I found these records even more helpful. I'd always wanted to search out these records of Russell's father's sermons, of course, and was disappointed that none of them had been preserved in records thus far found. But it turns out, by going to the church itself and just asking everybody and never taking a kind no, it doesn't exist for an answer, I found at least one person in the church history was a diarist, the church organist, W.L. Swan, and he in fact kept meticulous records. And it turns out on the 3rd of December, the Sunday prior to the transit, Swan recorded, quote, "The sermon was about the transit of Venus, which will occur on the 6th next. Swan, the organist, played The Heavens Are Telling from Haydn's creation, and he even noted that the weather was cold and with blowing wind. There was also a note penned that mentioned the excerpt from Proctor that was in the Enterprise that appeared in the local paper. But for Swan, the pastor was the center of his attention. Mr. Russell's sermon was the best I'd ever heard in the church. It was splendid." As I continued to go through Swan's records, I found that he discoursed, Alexander Russell, discoursed more than once from the pulpit on the wonders of heaven and nature, and of the human desire to know. From the titles recorded by William Swan among the 2,500 sermons his minister preached, one can find astronomical themes, in fact, quite a few. Favorites were seasonal changes and upcoming eclipses. At times, Swan found Russell's sermons uninteresting, more like an essay than a sermon. But Russell's sermons could also be moving, particularly when delivered without text or devoted to the questions of temperance and church reform, which were the two top topics for that church. In these times, Alexander Russell's sermons were always listed as a triumph and would always put in a comment like he was a priest to be proud of. So I felt I was getting closer to my quest. but I still couldn't prove that Russell's memory was correct, but it was getting pretty likely. Reports of the day of the transit were few in either the Oyster Bay Guardian or the East Norwich Enterprise, but they certainly were there. I'd hoped that, there would be a report about the pastor showing his son the transit. No, that didn't happen, Well, the most telling report, though, came from the Enterprise on Saturday, 9th of December, 1882. It has nothing to do with the pastor, and you'll see why in a moment. It was an embedded story in a social column on viewing the transit the previous Wednesday. And they were basically excerpts from townsfolk talking about their experience. But the one I'll read to you is the one I found least enlightening, but most curious. A local personality in raconteur, Saul Townsend, was standing on the corner at 2 p.m., and presumably that was a corner of East Main and one of the other main cross streets, well after the transit started. But he was distracted by three pretty young women who were delicately transiting the muddy road, which told me that, of course, there had been rain. Affixed on this local terrestrial vision, he lost all interest in the transit. Later, when asked if he had seen the transit, he remarked, "I have, but not the kind perhaps you were thinking of. The one I allude to needed no smoke glass. Everybody is making fools of themselves today, looking for Venus through a glass, darkly, craning their necks, peering in the heavens. But the Venus I take stock in is peculiar to this mundane sphere and delightful to behold, when the sun shines or the moon or when the crossings are muddy." Well, the streets were definitely muddy from a recent rain, but the skies had definitely cleared, and from this kind of accounting, it is quite evident that everyone knew of the transit in Oyster Bay. It was visible, and people looked to see it. Well, without absolute, total, complete truth that little Henry attended his father's service that day, but it's likely that he did, and without any actual record of what went on that day among the Russells, history is left to speculate, but I'm feeling pretty comfortable at this point. In their spacious manse, I know from the nature of the Russell family that it is quite likely that the topic of the transit was discussed probably that day and probably for several days prior in the Russell household. From all I know of the pastor, he wasn't one to hold back in showing nature to his sons. Topics for sermons came from topics around the dinner table, and there's every indication that the pastor and his wife often engaged in active intellectual discussion around the table. Generally, the Oyster Bay townsfolk of that day who wrote in the local paper commenting upon recent sermons wanted to see science in support of religion. And this is, again, an attempt to get a sense of what the conversation might have been like around the Russell table. When people wrote in discussing issues raised by these sermons, they were about science in support of religion. John William Draper was usually referred to as the arch-evolutionist, who was seen as an oppositionist by the good folk of Oyster Bay, trying to keep science apart from religion. On one occasion, another reverend in town, the Reverend Talmage, a pastor serving nearby Locust Valley, argued that when evolution shall have accomplished its design, no priest or self-assumed intercessor will be needed. Herbert Spencer's dictum that science is simply a higher development of common knowledge was welcomed by the locals, one arguing, in fact, that the discoveries of science from the time of Newton to our time confirm the dogmas or doctrines of the Church. Nearly all the great astronomers from Copernicus to Mitchell, an interesting quote here, have been believers in the Bible and the dogmas of the Church. The writer was E.S. Heberd of Port Chester. Well, understanding and appreciating the transit, therefore, was important, I think, to the typical inhabitant of Oyster Bay. Add to that the fact that 1882 was an unusually exciting year for astronomical events. It included a spectacular daylight comet the previous September. It included the predicted return of a comet called Wells. It included a near-total solar eclipse in May, during which time yet another sun-grazing comet was discovered and widely celebrated. Well, all of this activity could not have failed to heighten excitement about the events of Wednesday morning, December 6th. So what I can say without question is that Russell recalled the excitement of the day among his parents and among the parish. Most likely he viewed the event as we see here through smoked glass. Well, let's move on from Russell for a while. Another young fellow who eventually became a pivotal name in American astronomy recalls the 1882 event as also being significant to the growth of his life's ambitions. The young George Hale, then about 14 years of age, had already shown a strong interest in the microscopic world of rocks and bugs, but he was also branching out to greater realms. He tried his hand at making a telescope using some simple lenses at hand, and in November 1882, he showed his handiwork to an odd wizard-like man who seemed to live his nights anyway, in a cheese box-like structure peering at the heavens. Well, that man was Sherborne Wesley Burnham, a famous double-star observer, and he didn't think much of Hale's little toy telescope and suggested that Hale find a better telescope. Burnham, in fact, knew of a 4-inch Clark telescope that was available, and by the time young George got home, he had a whole argument laid out for his wealthy father. The transit of Venus stood at the top of his list of things he just had to see. The telescope did show up on time for the transit, and George happily observed it out the window of his mother's room. This is George Hale at about that time in his soon-to-be-called Kenwood Observatory. Well, telescopes of that size were in fact readily available. Notices in the Sidereal Messenger, in fact this is the December 1882 issue, made that clear, as did frequent notices there from owners interested in stepping up to larger glasses. George, as we well know from the history of astronomy, did move on to bigger and larger telescopes, building the largest telescopes in the world at least 4 times. That the transit played a part in his memory of how he, too, gained a lifelong interest in astronomy once again attests to the larger importance of such events. Well, this is certainly true of Russell, and I'd like to get back to Russell for a little while, and then we'll go to the general interest. Russell returned to the solar parallax and to Venus several times throughout his long career, and there he is at graduation in 1897. As we've learned from the previous talks in this series, the results of both the 1874 and 1882 transits, in spite of the many successful observations, were really quite disappointing. Compared to those, David Gill's derived value of the solar parallax from the famous 1877 opposition of Mars proved to be far more sensitive. After both transits, funds were insufficient to properly reduce and analyze the American observations, and so their full value was never realized. In contrast, Gill's technique gained in popularity, as did a similar technique proposed by J.G. Gall in 1872 to use close passages of minor planets. Of course, no more transits of Venus would be available after 1882 until the 21st century, so all attention turned to other techniques, including Newcomb's suggestion that with a better determination of the velocity of light, experimentally, measuring the time it took to travel from the sun to Earth would yield a better value of the astronomical unit. This method, in fact, based upon a reversal of Olaus Roemer's original technique of determining the velocity of light by observing the times of eclipses of Jovian satellites, was employed from time to time by Newcomb and by R.A. Sampson. But the most exciting technique was the technique of near-Earth passing asteroids, because for those parallaxes, direct parallaxes, could be measured highly accurately. As Russell was completing his undergraduate studies in astronomy in the 1890s at Princeton and was entering graduate work, a new minor planet named Eros was discovered and soon was found to have an orbit that would bring it extremely close to Earth, providing an excellent opportunity to improve knowledge of the astronomical unit. Gill had already used the asteroid technique, refining it using heliometer observations of asteroids, and the close approach of Eros in January 1901 drew great excitement from astronomers. Russell participated in two ways. First, his doctoral thesis was a study of the orbit of Eros and perturbations upon it caused by Mars. And second, using that information, as a postdoctoral student at Cambridge, Russell aided A.R. Hincks in the reduction of photographic observations of the minor planet. The results of the Eros campaign, as it was called, agreed closely with Gill's measurements and with subsequent studies based upon geometrical, gravitational, and velocity of light methods. And all of these allowed Russell to conclude, by the time that he was very much the central figure in American astronomy in the 1920s, in a textbook that he wrote with Dugan and Stewart, that the future of the transit of Venus really was not one of science. It is not likely, he wrote, that so much trouble and expense will hereafter be expended upon observations of transits. Other methods of determining the solar parallax have been found to be more trustworthy. Well, even though Russell was undoubtedly right, one concluding benefit of the 1882 transit he overlooked was that it indeed played a part in bringing him into astronomy, for he was to become one of its most valuable and powerful practitioners in the first half of the 20th century. Russell's encounter with Venus definitely stayed with him all his life. In 1898 and 1899, he synthesized diverse sources of data and generated a theoretical model that could use the observations of the extent of the cusps of Venus, how far they extend beyond how far they should extend. Here's another good example. Venus, when it's very, very close to being exactly between the Earth and the Sun, but not exactly so you still see a bit of a lighted half. And when we talk about cusps, it's the sort of the horns of the illuminated part. They extended farther than they should by geometrical considerations. And Russell studied this kind of extension and generated a theoretical model that could explain the extensions of the cusps of Venus. He was the first to argue correctly that the extension was caused due to an atmosphere that was a scattering atmosphere, an atmosphere that primarily scattered light rather than absorbed sunlight. And when he did this, this was of course before atomic scattering theory and atomic absorption were really known in any detail, but he deduced it quite accurately. And he was one of the first to interpret an extraterrestrial atmosphere in terms of scattering theory. Well, Russell's attraction to bodies like Venus and Eros didn't escape notice of his more creative classmates at Princeton. A few years later, Russell dutifully reported to his class of 1897 secretary, John Henry Keener, quote, "I confess that I took up work relating to Venus of my own free will." The romantic titles in his Vita, Russell feared, which he'd been getting chided for, which by then also included notices on predicted places for the recently discovered minor planet Eros, should not be misconstrued, he said, as any particular desire for the comforts of flesh. I'm really not to blame for that. I was very sorry to read this because I realized the sales of my biography would go way down as a result of that. But nevertheless, his classmates and, it turns out, students at Princeton continued to giggle about this in various spirit magazines well through the first half of the 20th century. I was totally confounded by it. Anyway, aside from Russell and Hale, though, what was the public response to the 1882 transit? In the time remaining, we'll explore some indicators. As we've heard in earlier lectures, Washington composer John Philip Sousa was certainly aware of the transit. Moved by the event, he composed a march for the unveiling ceremony of the statue of Joseph Henry, the first secretary of the Smithsonian Institution. Henry, as we know, was on the U.S. Transit of Venus Commission, which was a body of highly visible dignitaries, scientists, and statesmen. And they were assembled to coordinate activities relating to the transit, but they also spent considerable effort hyping it, advertising it. Organizing in 1870, the Commission was duly sensitive to its mission to convince the nation, the government, and its people that the United States was up to the task. It is not likely that our government will be backward in furnishing the means to enable its astronomers to take part in this work. The principal dangers are, I apprehend, those of setting out with insufficient preparation, with unmatured plans of observation, and without a good system of cooperation among the several parties. For this reason, I beg leave to call the attention of the Academy, and this is the National Academy, to a discussion of the measures by which we may hope for an accurate result. And this was quoted from Frederick True's Semi-Centennial History of the National Academy of Sciences. Now, that's a very curious statement in light of what the Commission actually did, and that relates to the popularity of the transit. Because the preparations for the 1882 event, as I've already mentioned, included a public appeal to help out every possible person with a telescope, with anything. Please help. And Steve Dick has written about this to some extent in his History of the U.S. Naval Observatory, Chapter 7. And he wrote, instructions for optical observations of contacts were extensively distributed throughout the country, and Western Union supplied the observatory's time signals to anyone in the country intending to observe the transit. As a result of this effort, which resulted in bringing nearly every telescope in the country into action, and that's a quote that Steve used, the Transit of Venus Commission received 93 reports of observations from individuals as distinct to official eclipse or transit parties. Steve doesn't, for the purpose of his book, he didn't explore the reasons why the Commission made this public appeal. But I'm kind of curious about that. And in the time I've devoted to examining the records that are right here in the National Archives, I didn't find a clear rationale either. So I think it's a very interesting question to ask, but I leave that at the moment to some hardy soul possibly in this audience to look into the why. Because I've seen this now more and more often. It's much more characteristic of 20th century science, where you have a commission that has a dual function, to raise public awareness, which in turn will raise support for the actual activity. The extent to which this is a fact for that period of time is not clear. It's very clear in the work I'm doing today on the Smithsonian Astrophysical Observatory. Okay. I did take considerable pleasure, though, plotting through some of the records that Steve identified in his history, and I'd like to share some of them with you concerning who responded to the appeal of the Commission. First, it seems that virtually every major newspaper in the land and many journals and magazines, both here and overseas, repeated the Commission's plea. Many of the letters of inquiry to the Naval Observatory identified where they had seen the announcement, and distribution was legion. Most of the some 200 preserved inquiries in the National Archives merely asked for the government pamphlet of instructions on how to view the transit. But some writers proudly described their equipment. And typically, they possessed 3 to 5 inch Clark refractors, some as large as 7 inches. They also identified their clocks, their watches, and a few even possessed recording clocks or chronometers, and some had small Fouth transits. Most of those who identified themselves by their full names were male, but there were some women, notably a few from the Boston area and from Brooklyn. Sarah Day, Florence Chase, and Alice Dinsmore unfortunately only asked for the pamphlet, saying nothing about what their plans were for observing the transit. Alexander Evans of Elkton, Maryland, asked for the directions, but admonished the Commission to send out better information to newspapers far and wide as to the simplest means necessary to detect and identify Venus, but with the protection to the eyesight, as he said. Reports from many of these writers started flowing in immediately after the transit. Here's a very proud watchmaker sending in his single observation from Alamosa, Colorado. I think you can read that. Transit of Venus past sun disk, 1 o'clock, 12 minutes, 15 seconds, Denver time. Thank you. Okay. The city engineer's office in Denver, Colorado, provided details of the location of their observer. Mr. James R. Jorgensen of New York City's Maritime Exchange submitted his observations in watercolor. A German observer who was in the United States, I think, recorded not only first and second contacts, but a premature third contact with a cloud front. And a proud and dutiful draftsman submitted his fine drawings on blueprint stock. And this is representative of the kinds of the enthusiasm, the amazing enthusiasm that these people had for the transit. Some of the reports by individuals again repeated descriptions of their instruments, their locations and weather conditions per the instructions of the government pamphlet. Their ability to report position and timings, however, varied widely, and some neatly communicated their limitations. Mr. Hess was assisted in his duties by Mrs. P.B. Hess, boasted a small transit instrument by J. Brown and Sons of 1-inch aperture, an equatorial telescope of 2 5/8 inches aperture, a Wheeler mean time clock made in Elgin, Illinois, and a Troughton sextant and artificial horizon. He was generally known as a dutiful reporter to the Smithsonian, and in 1880 he stated that his personnel and equipment of his little station, as he called it, remained active in solar observations. But he couldn't ever bring himself to describe, he said, his outpost as an observatory, though his work had been honest over the years. And this is from Holden's report of astronomical observatories, Smithsonian in 1880. We used to collect all that kind of information. But then there are some rather impressive installations. John N. Stockwell of Cleveland, Ohio, turned his private observatory to the task. It included a 5-inch equatorially mounted Clark, a tall case Howard clock with a telegraphic connection, and an Alvin Clark & Sons chronograph. Stockwell was identified as a professor in the listing of the Naval Observatory, but his observatory does not appear in any of the compilations of the day identifying professional installations. Among those reporting individuals, as Steve said, some 93 in all, a few were recognizable, like E.E. Barnard, Herbert Hale, Winslow Upland, Charles Hastings, and E.S. Holden. Some were not yet established, but all recognizable. Many more came from just a few disciplines, like professors of astronomy and mathematics. But reports also came from city engineers, from surveyors, and professors of engineering. There was a solicitor of patents, and the Office of the Commissioner of the Department of Health of Brooklyn, New York, also pitched in. The Denver Cement and Manufacturing Company was represented by an observer, as was the New York City Maritime Exchange and other bodies interested in navigation, in wayfinding, and the like. Well, with this kind of public reaction, I think is really quite marvelous to behold, and I'm not exactly sure what to make of it. Maybe we could discuss it in the question session. Princeton's C.A. Young, of course, compiled the official record of all known observations of the transit from official parties, and he counted up some 39 in all on American soil. They were, of course, distinctive as being almost completely photographic, or they used sensitive heliometers. All of the respondents to the commission, however, who were labeled as individuals, were visual observers, and there was no overlap. Beyond the active observers, there were numerous social and cultural spin-offs. Of course, we already mentioned Sousa's efforts, but there were some other interesting ones that bear mention. Apprehensive about the weather a few days before the transit, a local astronomer in Phelps, New York, a local person identified as an astronomer in Phelps, New York, made a public plea asking, quote, that prayers be offered on Sunday next in all the churches for clear weather. Okay, perfectly okay. And it was titled Prayers for Astronomical Science. We get those prayers these days, but it's for other reasons. Okay. The reporter added that the solution to the sublimest problem known to science is to be attempted on that occasion, the opportunity for which will not occur again for 122 years. Millions of dollars and months of valuable time have been expended in preparations for the great event. The New York Times repeated a proclamation about the transit made by the Providence Journal a few days earlier. Quote, no intelligent person who realizes its importance will fail to do as much toward the celebration of the rare event as to follow the planet's course with the aid of a piece of smoked glass. It was almost like a mission. The column now this is after the transit. The column Art Notes in the New York Times reported in June 1882 that a French porcelain company, Sèvres Manufacturing, was finishing a large vase decorated and designed by Joseph Cheret to record the expedition for observing the transit of Venus. Apollo sits on a throne, behind him is a sunburst, and he holds a lighted torch. Venus is represented by a nearly undraped figure with long hair, which passes before the throne. Her right hand is raised to shield her eyes from the splendor. Her left is stretched forward and holds a star. The only grumble that the New York Times critic had was, quote, that the colors are said to be in the best style of the famous but now somewhat degenerate foster child of the French government, unquote. After the transit, mention in the press came from far and wide. There was a comic representation of the transit of Venus. I would have loved to have seen that, as well as representatives of all 4 points of the compass, and these were all children, who were part of a parade, featured as part of a children's carnival and charity ball in New York that was patronized by Governor Grover Cleveland. Hardly a day after the transit, the New York Times also reported that the transit of Venus had a remarkably exhilarating effect yesterday upon pugilistic society. The reporter proceeded to describe how what had been a stalled chain of events keeping Tom Allen from fighting John L. Sullivan was suddenly broken by others throwing their hats in the ring and betting large sums that they could beat Allen. In following years, the transit cropped up a few times in political speeches and general oratory reported in the press, as well as in stage plays and courtroom trials. In 1891, one senator invoked the rarity of the transit, he said, the rarity of the transit of Venus, and he compared it to assessing when Indian territories will be divided into distinct governments. A New York Society note in February 1894 reported that Miss Edwina Hamlet hoped to become an astronomer, giving public talks, and that she was inspired by the transit of Venus. When a hapless military inspector was arrested and accused of perjury in 1895 and was subjected to a court-martial, he received a temporary reprieve, and the reprieve was on the basis that he served as a member of the U.S. expedition to New Zealand to observe the transit of Venus. Work of this sort may well have been held up as a patriotic duty, akin to serving in a foreign campaign. Well, the last transit came at a time vastly different from our own. It was a time when the common man, and maybe even a woman or two, could hope to contribute in some small way to the advancement of knowledge about the universe. It was indeed a different time. The 1882 transit came 5 days before a theater was first lit by electric light. It came at about the time the Statue of Liberty arrived in the United States and took place just before the opening of the Metropolitan Opera House in New York. In his closing remarks to one of his first reports on the data collected from all stations, C.A. Young of Princeton hoped that with sufficient support by the government, still hoping for that support, of course, the data would eventually repay the great cost and effort, with a result that cannot fail to be of the highest value in setting the dimensions of our universe. Well, while Young's hope no doubt dimmed in following years, the transit did play out an important part in bringing to Princeton the best student he ever had, or probably could ever hope to have, and that was Henry Norris Russell. Russell was one of his last students and occupied a distinguished chair in his name until the mid-20th century.